All right. Hello, everyone, and welcome to the Unit 4, Day 9 lesson. This is going to be a continuation of talking about area and circumference for a circle. So if you recall last night, if you had me as a teacher, this is your homework assignment from last night. So if we look at one specific example, and you can pull up the answer key to look at all of them, but just looking at one specific example, example number 1, you'll see that you list the radius, diameter, and that allows you to then find the area and circumference. So in order to do this worksheet, you had to have two main formulas, the formula for circumference and the formula for area of a circle. Now, when you're looking at those two formulas, you will notice that the circumference formula asks you to use the diameter and the area formula asks you to use the radius. So in all of these cases, you will see that you are asked to find both the radius and the diameter because it helps you to find either the circumference or the area. Now, a reminder, if you look at example number 1, you have the entire length here. That is why the line is drawn all the way through. That is saying that the entire length of this from side to side is 8 feet. That makes it the diameter. The radius is always exactly half of the diameter. Now, if you look at example 2, this line is only drawn through half of the circle, making that the radius. If you want to consider the entire diameter, you need to have 2 of the radiuses, or radii, and therefore the diameter is 14. If we go back to today's notes, again, Unit 4, Day 9, it asks us to again write the circumference and area formula because we will be needing those today. A reminder, the circumference formula is going to be C equals 3.14, also known as pi, times the diameter. I'll put a little multiplication symbol there, multiplied by the diameter. The area formula, on the other hand, is going to be 3.14 times r squared. Okay, so again, keep those formulas in mind. Those formulas will be given to you on your formula sheet. Whether you want to consider that as pi or 3.14 is really up to you. So now if you look down to the next section, you have a little warm-up that again basically asks you to do exactly what you did in your homework, but be a little more specific. So the first one says to calculate the diameter. And so example 1 is looking for you to find your diameter. Now example number 2 is only asking you to find the radius. So again, these first two examples are not asking you to find the entire circumference and area. It's just asking you the diameter radius. Then example 3 and 4, this time you are finding the area and the circumference, so please make sure you're paying close attention to which one you are trying to find. So go ahead and pause this video for a second, and it should only take you a minute or two to calculate all of these. And when you are good and ready, you can bring this video back on, and I will walk you through each of these. Now, example number 1, like I said, is asking you for your diameter. That should be from one side all the way through the other. Please remember that diameter should be going through the center of your circle. You cannot have your diameter going from this point to this point because that's not going through your center. So if I want it going exactly through my center, and from this point to this point, from the center to the edge is 2.2, then my diameter is going to be twice that. So my diameter is going to be 4.4 millimeters. Okay, and again, you're just doubling that. Number 2 is saying that the diameter going from side through the center all the way to the other side is 7.3. So in order to find the radius, you're going to want to take 7.3 and divide it by 2, and that gives you a radius of 3.65 meters. And over here I could label this as diameter. So those ones, again, just kind of making sure that you can work interchangeably between radius and diameter, because sometimes it'll give you the radius and you're looking for the diameter, so you know how to kind of convert between those two. Now, example 3 is asking you to find the area. So if you consider your area formula, that area equals 3.14 times r squared, then I come down here and say, oh, I have r. Perfect. So I'm going to take 3.14 and multiply it by a 3.6 squared. Please remember that we're doing the 3.6 first. So I do 3.6 squared should give me a 12.96. And then I go ahead and times that by my 3.14 to get an area of 40 point, and you can round if you want, 7. Don't forget your units. This is meters, and because it's area, it should be meters squared. Then we go into the next example. The next example asks for circumference. So my circumference formula is 3.14 times diameter. Conveniently, I do have my diameter in this problem, so all I have to do is 3.14 times 6, and you get your final circumference to be 18.84. Again, if you wanted to round that to just 0.8, that's fine. Don't forget your units. That's millimeters. And this one is not squared because circumference is not two-dimensional, it's one-dimensional. All right, so again, a good little review of kind of what we did yesterday. And now we are going to learn something slightly new. So before we scroll right down into the next page, I want you to consider something. If I gave you a problem that said, let's go old school for a second, and it said that you have 2x equals 4. If you had this and I asked you to solve for x, what would you do? Think to yourself, what would you do for this problem? 2x equals 4. Well, hopefully after thinking about it for a second, you'd be like, well, I would just divide by 2. I would get x equals 2. That's perfect. Now let me ask you another question. Let's say that I had the problem 2x squared equals 4. Actually, let's change that number for a second. Let's make it equal to 8. Okay. If I asked you to solve this problem, you'd probably be like, well, okay, I'd probably do the same thing as I did over here. So let me go ahead and divide by 2. That's going to give me x squared equals 4. But now here's where it differs from the previous problem. I have an x squared. How would I get rid of that x squared? Think to yourself, what's the opposite of x squared? Well, you're like, okay, what's the opposite of x squared? You can't really divide it by 2 because dividing by 2 is if I had a coefficient, a number out in front. This is an exponent. How do I get rid of an exponent? What's the opposite of an exponent? Well, the opposite of a square is actually a square root. If I square root a square, that leaves me with just x. Now, if I did it to this side, I also have to do it to this side. And therefore, what does x equal? X equals, technically, plus or minus 2, right? So if you need to get rid of a square, you just square root both sides. Now keep both of those skills in mind because this is actually what we're going to be doing. We're going to be doing problems like this, where you're going to have to divide it in order to get x by itself. And we're also going to be doing problems like this that involve this square root down below. So let's come back to the notes and consider what we're going to be doing today. So down below, you'll find the question of, how can we find the radius and diameter of a circle if all we know is the area or circumference? So again, we're looking to find the radius and the diameter. So it's not as simple as saying, oh, well, if you have the radius, we double it, gives us diameter. Or if we have the diameter, we cut it in half, and that gives us the radius. It's not quite as simple as that because we don't know either of them. If you look at this picture, we don't know the length of anything in here. We don't have the radius, and we don't have the diameter. But what we do have is the circumference. So if I know the circumference, and we know the circumference formula to be circumference equals 3.14 times the diameter. There's my circumference formula. If I know the circumference, let me go ahead and plug that in. So I'm going to have 18.84, that was my circumference, equals 3.14 times diameter. Now there's a lot of decimals in this, so it can be a little tricky, and you're like, well, what am I supposed to do? Come back over here and consider when I just had 2 times x equals 4. We divided out the 2, and that left me with x. So if I come back over to this problem, that's really all I have, is I have this number times a variable equals this number. So if I want to get diameter by itself, what's the opposite of multiplication? The opposite of multiplication would be division. So if I divide both sides by 3.14, over here the 3.14s will cancel each other out. And on the other side, I will have, let's see, I got to calculate that, 18.84 divided by 3.14 gives me 6 to be my diameter. So I can come down here and write 6 for my diameter. That now allows me to find my radius, which is going to be exactly half, to be 3. So as far as, really learning something new here, it can be a little challenging as far as setting it up and maybe possibly solving it goes. But I remind you, it's the exact same process that we did over here with these two. We just divided by the 2. That helped us eliminate the 2's and got us x by itself. Okay, so keep those 2 methods in mind. Now we go on to example number 2 here, and this time it's talking about area. So if I consider my area formula, area equals 3.14 times radius squared. We don't know radius, we don't know diameter, so this r is going to be a mystery. But we do know our area, so I can set this up and say that I have 40.69 equals 3.14 r squared. So very similar to the examples we did up here, we need to get rid of that 3.14. So I go ahead and divide that by 3.14. So I have 40.69 divided by 3.14 gives me, and I'm running out of space, so I'm going to come over here, 12 we'll round that to 96, okay, equals r squared. And again, consider what we did up here. How do we get rid of an r squared? By square rooting it. Anytime you have a square, how do you get rid of it? By square rooting it. So if I go ahead and square root 12.96, that gives me 3.6 equals r. That is my radius, 3.6. 3.6. Now if I want to find my diameter, I times that by 2 because I need 2 of them. That gives me a diameter of 7.2. All right. So again, both of them kind of coming back to that concept we talked about over here. Either you simply divide it by 2, and that gives you your x value. Or over here, we had to divide first, then square root. Please remember that you cannot square root first, because if you tried to, let's just put this in a highlighter. No, we'll go in this mode. If I tried to square root that, then even the 2 is going to get square rooted, and you don't want that. That would not end well. So don't square root it first. Get rid of the 2 first, cancel those out, then you can square root that x. So again, I'm going to come back to that screen in case you want to pause it and look through any of that. But again, all we're really doing here is still working with those 2 formulas. There's the circumference formula, there's the area formula. But instead of simply plugging in the d or the r, simplifying, this time we're plugging in the c and solving for d, or over here plugging in the a and solving for r. Okay, once you find d or you find r, then you can go ahead and find the other, radius or diameter depending on the problem. Okay, so your homework is going to be on the next page and kind of giving you some practice with that. Those of you working on OneNote, you'll find it over on the side where it says Unit 4 Day 9 homework. Otherwise, those of you with the printed packet can just scroll down and you'll find the Unit 4 Day 9 homework. Okay, it again goes through, and this time it gives you area. Here's your area. You need to find radius. Here it gives you area, and you're finding diameter. So no matter what the problem gives you, go ahead and it might even be helpful to write up top here the area and circumference formula. That way you know what you're working with. But if you're working with area and they ask you to find radius, no problem. That's the first thing you found. If you're working with area and you're trying to find diameter, you're still going to need to find the radius in order to get the diameter.